Place Value by David A. Adler, illustrated by Edward Miller. A is both a word and a letter. 1 is both a number and a digit. A is the first word in the sentence, "A frog jumped onto my cupcake." A is the fifth letter in the word, cupcake. 1 is the number in the sentence, "We're number 1." 1 is the second digit in the number 318. We write words with letters. There are 26 letters in our alphabet. You know them all. Count the letters in the word banana. B-A-N-A-N-A is a word with 6 letters. We write numbers with digits. There are 10 digits in our number system. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Count the digits in the number 5,432. 5,432 is a number with 4 digits. Order is important in both words and numbers. Pot and top have the same letters, but because their order is different, the words are different. "I said, 'Hand me a pot, not a top,'" said the monkey. Cafe and face have the same letters, but because their order is different, the words are different. Not face, it's cafe. Switch the F with the C. Banana cafe, not banana face. 216 and 621 have the same digits, but because their order is different, the numbers are different. The place of each digit in a number determines its value. The 6 in 216 means 6 ones. The 6 in 621 means 6 hundreds. Very different values. 9,347 and 7,493 have the same digits, but because their order is different, the numbers are different. The 7 in 9,347 means 7 ones. The 7 in 7,493 means 7 thousands. Place definitely matters, right? Take a look at this chart. On it, you can see the value of each digit in the number 654,321. In the number 654,321, there is a comma after the 4. Commas are used to break large numbers into groups of 3 digits. We call those a period. We talked about that last week. The groups of 3 are counted to the left from the ones place. The commas make numbers easy to read. The first group of 3, 321, is read 321. The second group of 3, 654, is read 654,000. With the 10 digits in our number system, we can write even larger numbers. 2,426,782 is a lot larger. This number is read 2,426,782. The same digit, 2, in the same number, 2,426,782 has 3 different values. From the left, the value of the first 2 is 2 million. The value of the second 2 is 20,000, and the value of the last 2 is just 2. This guy says 2 million is a lot of bananas. He's right. Take a look at this place value chart. There's a dot to the right of the 1. That dot is a decimal point. It separates the columns of digits with values more than 1 from those that are less than 1. We talked about this past week. Each column to the left of the decimal point is 10 times more than the column before, and each column to the right of is 1/10 of the column before. The value of the 9 to the right of the decimal point is 9/10. We can write it 9/10 as a fraction. The value of the 8 in the second column to the right of the decimal point is 8/100. We can write it 8/100 as a fraction. Dollars, dimes, and pennies can teach you about the decimal point. How much money is in this box? If you write it in words, you will write $12.34. Don't forget the word "and" is used for a decimal point. If you write it as a number, you write $12.34. There is one $10 bill in the box. The 1 in $12.34 is in the tens place. It means $10. There are two $1 bills in the box. The 2 in $12.34 is in the ones place. It means $2. There are 3 dimes in the box. Each dime is 1/10 of a dollar. So the 3 in $12.34 would be in the tenths place. Tenths place. It means 3/10 of a dollar, or as we know, 30 cents. There are 4 pennies in the box in this last column. Each penny is 1/100th of a dollar. It means it would take 100 pennies to make one whole dollar. The 4 in $12.34 is in the hundredths place. Hundredths. It means 4/100ths of a dollar, or 4 cents. Our number system is called the Hindu-Arabic system. It was first developed in India a few thousand years ago and spread across the Middle East and to Europe. With just the 10 symbols in the Hindu-Arabic system, we can write any number, no matter how large or how small. It's place value that makes our system so powerful. Take another look at a place value chart. The first column to the right of the decimal point is for tenths, like we mentioned before. The first column to the left of the decimal point is for any number less than 10. The second column to the left is for tens. The third column is for hundreds. Of course, each hundred is 10 tens, right? The fourth column is for thousands, and each thousand is 10 hundreds, and each hundred is 10 tens, and each 10 is 10 ones. Do you see the pattern? The Hindu-Arabic number system is based on 10. Why 10? Many people believe it's because we have 10 fingers. Our number system may have started thousands of years ago when someone counted on his fingers. He reached 10 and made a mark on the ground to show that he had counted all 10 of his fingers. The mark on the ground meant 10. He continued to count. Each time he counted all of his fingers, he made another mark. So each mark meant 10. It's a very large cupcake they got baking in the oven. You know that 132 is not the same number as 123. And 123 is not the same number as 321. The digits in each of the numbers are the same, but the numbers are still different. Our number system depends on place value. It's what enables us to write this huge number using just 10 different digits. You ready for this? 329, 465, 180, 708, 643. Here we go. You ready? 329,465,180,708,643. Whew, that was a big one. Look at this. Now they're having to ice the big giant cupcake. 329 trillion. That's a lot of sprinkles. I don't know about you, but I could probably help eat this. It looks pretty tasty. And here's the back cover. Place value chart matches the inside cover. Place value, written by David Adler and illustrated by Edward Miller.